Hey guys, welcome to Unit 11, Lesson 2. Our topic today is related rates and volume. I want you to pause the video and try the warm-up. The warm-up says a square shrinks so that the length of its diagonal is decreasing at a rate of 8 meters per minute. So you have a square. Let's sketch a square, right? All sides in a square are equal. That's my diagonal. And the rate of change at which the diagonal is decreasing, so let's call lowercase d as d, we're doing with respect to time as what? 8 meters per minute. But wait a minute, it said decreasing, right? So it's going to be negative. So be very careful of that, okay? Otherwise you'll end up with like crazy answers. So that's what it is. I know this is my diagonal. I just sketched the diagonal. And it's also asking me at what rate is the area of the square changing. So I want to find dA over dt. I don't know that. When the diagonal, I know d is 5. Okay, so now if I want to find dA dt, so I need to start with the area formula. I know my area is what? Side square, right? But if I took my differential equation, or if I took the derivative on both sides, I get 2s ds dt. But see, neither do I know ds dt, nor do I know s, and I want to find dA dt. So I don't know any of these variables. But I do know about my diagonal. So can I write my s in terms of d? So let's try and figure that out. How would we do that? I'm just going to erase this. So I know my side square, this is my d, this is my diagonal, these are my sides, right? And this is a right triangle, so I can use my Pythagorean theorem. So s square plus s square equals d square. So it's 2s square equals d square. I want to solve for s square. So s square would be what? D square over 2, right? Why did I want to solve for s square? Because I have s square here. So I can say area is same thing as d square over 2. And now I'm going to take the derivative. So if I take the derivative now, I would have all the variables except for my dA over dt, right? So it's dA dt we are differentiating with respect to t. This would be what? Think about it. It is just 1/2 x squared. What would be the derivative of that? It would be just d, but since we're differentiating with respect to time, we have to write dd dt. So now substitute in. So my d is what? 5 times -8, which is -40. And since area is squared, so meters squared per minute, right? So area is, the negative is just telling me that the area is also shrinking, right? That's what the negatives and positive means. So now we are going to be doing some volume problems. So let's get started with example 1. It's saying the sand is falling off a conveyor belt at a rate of 12 cubic feet per minute into a conical pile. So look here, the units also kind of help you determine what this is. Cubic feet. So what would that be? That would be your cubic feet has to do with volume, and this is what? Time. So actually going to use 2. So we are differentiating with respect to time. So that's how you can even determine that. So I know my dV over dt is 12. Although it's falling, but it is building up a conical pile. So would you agree that your conical pile will be increasing, right? The height of it or the whole volume of it would be increasing. So it's going to be positive feet cube per minute. I'm going to sketch a cone here. Your cone is just something like, right? So if there's a conveyor belt here, it's dropping this, and this pile is increasing. Okay, then it says the diameter of the pile is 4 times the height. So the diameter is 4 times h. And it wants us to find at what rate is the height of the pile changing. So I want to find dh over dt. That's my question mark. When the pile is at, or the height is 10 feet. So the volume of the cone is given to you, but here you see two variables. Whenever you have two variables, you want to find dH dt, right? So can I write my R in terms of h? That will help me out. So I already know d is equal to 4h. So what is d? D is diameter. So can I not say 2r equals 4h? So what would r be? R is equal to 2h. So I'm going to take that and I'm going to substitute that in. So I know my volume is 1 over 3 pi r square h, which is 1 over 3 pi, what was my r? 2h square times h, which is 1 over 3 pi 4h cube, right? I'm going to simplify that, and that would be 4 over 3 pi h cube. And then I'm going to take the derivative. So now let's take the derivative of this. It'll be what? dv dt equals, so you're just basically taking the derivative of h cubed. So the 3's cancel out, so it'll be 4 pi h square, and we're going to write dh dt, right? So now I'm going to just substitute everything that I know. I know my dv dt is 12. 4 pi, my h is what? 10 square, and dh dt. I'm going to divide by, this would be 400 pi. So 12 over 400 pi equals dh over dt. So 4 times 3 and 4 times 100. So dh dt is 3 over 100 pi. And this is this is just the height, right? So it's going to be feet per minute, right? Okay. Next question. It's saying a spherical balloon is deflated. Deflated means what? The volume is decreasing, right? So at a rate of 256 pi over 3 centimeter cube per second. So my volume is decreasing, meaning it's going to be negative over 3 centimeter cube per second. At what rate is the radius of the balloon changing? So I want to find the rate at which the radius of the balloon is changing. So dr dt, I don't know that when the radius is 8 centimeters. So this is your, right, this is what it looks like. Your radius from here is 8, and this is something like your balloon would look like. That's the best picture I could sketch. So our volume for the sphere is given to us 4 over 3 pi r cube. We only have one variable, so we don't have to kind of worry about the others. So I'm going to take the derivative on both sides with respect to t. It'll be dv over dt equals 4 pi r square and then dr dt, right? So now all I need to do is substitute in. My dv dt is negative 256 pi over 3 equals 4 pi h square dr dt. So I'm going to divide this by 8 squared is 64. 64 times 4 is 256. So basically my 256's will cancel out. So I'll be left with, and the pi's will cancel out, right? If you know what I'm talking about. This will be what? 256 pi equals dr dt. These cancel out, so I'm left with dr dt is what? Negative 1 over 3. So the radius is also decreasing centimeters per second. Okay, so I want you to finish up the remaining questions or the remaining lesson for homework. And if you have any questions, please feel free to reach out.